All right, so hopefully you had a chance now to go through and practice them. So we're going to pick back up at number 4. So I have 2 hydrogen, 2 hydrogen, 2 oxygen, 1 oxygen. So remember, when we've done everything we can and somebody's odd, we're going to double it. So I'm going to make this a 2. That gives me 2 oxygen, 2 oxygen. That gives me 4 hydrogen. Put it over here to get the 4 hydrogen. Okay, so now we take a look at this and we see that we've got 2 things coming together to form one product. Remember, if we get one product, that is a synthesis reaction. And I'm just going to put S for synthesis. Okay, so we did number 5, so let's skip to number 6. So I have 1 aluminum, 2 aluminum. So I'm going to come over here and put a 2. Now that gives me 6 bromine. 2 times 3 is 6 bromine. Come over here, I have 1 bromine, so I'm going to put a 6 in front of it. Now that messed up the K's, so 6 K's, 2 K's, that gives me 3, so there's 6 there. That gives me 3 SO4s, 3 SO4s were balanced. Okay, now we take a look. We had aluminum and bromine and potassium and sulfate. So if 2 things are switching places, aluminum would take sulfate, potassium would take bromide, which is exactly what happens. So this is a double displacement, and I'm just going to put DD to show that. Okay. All right, number 7. We're going to start with 1 carbon, 1 carbon. Number 7's reaction is one that we haven't talked about yet. Okay, so let's balance it first. I have 1 carbon, 1 carbon, 4 hydrogen, 2 hydrogen. So I'm going to fix it and give myself 2. Now on the product side, I have 2 oxygen plus 2 oxygen, so that's 4. Over here I have 2, gives me 4. Okay, so everything's balanced. So balancing isn't hard. Now, here's the thing that you want to look at. Notice this is the oxygen, okay, and that he's splitting into 2 places is what it looks like. So we started with what we call hydrocarbon, which means that there's a carbon and there's a hydrogen, okay, and it's reacting with oxygen and to give us carbon dioxide and water. This is what we call a combustion reaction. This reaction right here is actually how we set your hands on fire. We took methane gas, added a little heat, and mixed it with the oxygen in the air, and a reaction occurred that gave us carbon dioxide gas and then water out of that. So anytime we see an oxygen by himself as a reactant, he is going to be a combustion reaction. So let's go back up and look and see if this has happened, and notice number 4, yes, this is synthesis, but it also was a combustion reaction because this had the oxygen and then it was coming together on the other side. Okay, so if you see oxygen by himself or as a diatom, as a reactant, it's going to be a combustion reaction. So notice 8, 9 are all going to be combustion reactions, and I'm going to just put C and C for that. Okay, so let's go ahead and balance 8, see how you guys are doing the balancing. So 3 carbon, 1 carbon, I'm going to make it 3. 8 hydrogen, 2 hydrogen, so I give it a 4. Okay, that gives me 4 plus 6, so 10 oxygen on this side. Over here I had 2. 10 divided by 2 is 5. We're done. Okay. Next one, we have 8 carbon, 1 carbon. So I'm going to make that 8. We have 18 hydrogen. Over here, we've got 2. So that's 9. So we've got 8 times 2 is 16. Plus 9 is 25. 25 cannot be divided by 2. So remember what I told you earlier. If something's odd and it's causing problems, you double it. Okay, so that means this guy is wrong. So double 9 to 18. Double the 8 then goes to 16. This one goes to 2. All right, so when we doubled the 9, it became 18. So 18 times 2 is 36. 2 times 18 is 36. 2 times 8 is 16. That gives me the 16 carbon. All right, now let's add up the oxygen. 16 times 2 is 32, plus 18 is 50. 25 O2s will give me 50. Now here's a hint. Whenever you do a problem like this, like a combustion problem like this, when you've doubled it, the number that you were looking for, so we originally were at 25 and we were trying to get that to not be 25, we needed to double it to get it 50. The number you're always looking for then, that 25, will always wind back up here, if that makes sense. As you see a couple more, it'll start to make sense. So remember, once you've done everything, you've got somebody odd, you double it, and so that number that was the odd number is going to end up here on that oxygen. And we already said that was a combustion reaction. Let's look at number 10. So we have Fe, Fe, 3Cl, 1Cl. So I'm going to make that a 3. That gives me 3 NAs, 1 NA. so I'm going to put a 3. That gives me 3 OHs. 3 OHs, we're balanced. Now we have FeNCl and AOH. So if a double displacement is taking place, two things have to switch. Fe would take the OH, Na would take the Cl, and that's exactly what happens. So this is a double displacement reaction. Number 11, phosphorus plus oxygen gives me diphosphorus pentoxide. So I've got 1 phosphorus, 2. Now, I could go ahead and put the 2, but I'm noticing that this oxygen is going to be odd. So instead of having to cross things out, I'm going to go ahead and double this to make him 10. That makes this 5. 4 phosphorus. So you could have gone through and done it, but then you have to erase. I just noticed, hey, my next step is going to be an odd number oxygen, so I doubled. We've got 2 things coming together to give me 1 product. That's a synthesis reaction, but also notice oxygen is one of my reactants. This is also a combustion reaction. Number 12, I've got 1 Na, 1 Na, 2 hydrogen. This side has 3. Okay, see if anything else will make it work. 1 oxygen on the reactant, 1 oxygen on the product. All right, so this hydrogen right here is causing me grief. So I'm going to double him. That gives me 2 NAs. Okay, that gives me 2 hydrogen plus 2. So there's 4 hydrogen on the product side. Now there's 4 on the reactant side, 2 oxygen, 2 oxygen. Okay, we've got Na and H2O, which actually H2O is going to break out into HOH, is how that's going to come together. So Na is going to go with the OH, and hydrogen's left alone. This is a single displacement or single replacement is another way we could call it reaction. Now, with the single displacement, remember you could have cat or and, so we have to look and see who was switched. Sodium booted out hydrogen and took the OH, so this is actually a cat ionic, single replacement or single displacement. Okay. Number 13, we've got 2 Ags, 1 Ag, so I'm going to put a 2 there. That gives me 1 oxygen, 2 oxygen, so this guy has to be doubled, which means he has to then go to a 4. Okay, we've got 1 reactant breaking down into a couple products, so this is a decomposition reaction. Number 14, we have S8 mixing with oxygen gives me sulfur trioxide. So I've got 8 sulfur, now I have 8 sulfur. That gives me 24 oxygen. I need to make this a 12 to get me 24 oxygen. Everything's balanced. We've got 2 things coming together to give me 1. It's synthesis, but it's combining with oxygen. So it's a synthesis and combustion reaction. We'll come back to the next video and finish up with these.